Hello and welcome again. I will also be talking on differentiation this time, but at this point, we will be differentiating sine x and cos x. As I said, I'm going to prove to you guys why you differentiate sine x, why you're going to get cos x, and you differentiate cos x. You're going to get minus sine x. I will do sine x here, then cos x will be in the next video for the purpose of space, both hardware and software space actually. So I'm given y is equal to sine x. Now I did the video on first principle before this one, because here we're going to apply first principle. If you are just watching the video for the first time, you might need to get some understanding on first principle. So I said first principle is y plus change in y is equal to x plus change in x. That this is the value for my y and this is the value for x. So putting this here, I have y is equal to sine x plus change in x. Now, if you recall from your mathematics, I won't say algebra, I say trigonometric identities, you were told that if you have sine a plus b, where I'll say all told that this gives us sine a cos b plus cos a sine b. Now this was the basic thing that we thought in our trigonometric identities. So we are also going to be applying this here. So if I'm applying this in this particular situation, this is going to be my a, this is going to be my b, so that this is going to be y plus change in y equal to, okay, so y plus change in y is going to give me sine x cos change in x plus cos x sine change in x. Basically it looks simple. Okay, so let's move on. I'll take my y to this side, so it gives me y change in y to be equal to sine x cos change in x plus cos x sine change in x minus y. Now what is the value of my y? Sine x. So I'm going to input that here. Cos change in x plus cos x sine change in x minus sine x. Okay, at this point I think I'm going to change my marker. Okay, so if you know what there is sine x here, I'm going to have factorize. So this would be change in y is equal to, I'll move this to this point for easy, I'll move this to this point for easy factorization. So this gives me sine x cos change in x minus sine x plus cos x sine change in x. Okay, factorizing that, I have my change in y to give me. Now at this point, if I remove sine x out, I'll get cos x minus 1. That's sine x giving me cos change in x rather minus 1. So that if I multiply both sides by sine x, I still get this. All of it plus cos x sine change in x. Cos x sine change in x. So this gives me my change in y to be equal to, now I'm going to divide all through by change in x. So my change in y, change in x to be equal to sine x cos change in x minus 1 all over change in x plus cos x sine change in x all over change in x. Now I get my change in y, change in x to be equal to, this gives me sine x cos change in x minus 1 all over change in x plus, so this here gives me just cos x, cos x. Now I'm going to take the limit of the function, that's the limit of change in y over change in x as change in x approaches 0. Now in limits, you know this isn't going to give you mass error. Everything here will just give me 0. That to be 0 plus cos x. And that is simply going to give me cos x. All from sine x, we got cos x. So then basically we know that using first principle, the y dx gives you cos x plus the y dx of this. So thank you for watching. See you later.